Today in Algebra 1, we will talk about operations with exponential expressions. In algebra, numbers with exponents are called powers or exponential expressions. They can be multiplied, divided, or raised to powers. Here are rules for simplifying powers or exponential expressions. When multiplying powers whose bases are the same, add the exponents. Now 5 cubed times 5 squared. Technically, if we think about it, 5 cubed will be 5 times 5 times 5, and 5 squared will be 5 times 5. So 5 times 5 times 5, 5 cubed is 125, and 5 squared is 25. And if we multiply these numbers together, we get 3,125. We can definitely do it that way, or what we could do is we add the exponents. So 3 plus 2 equals 5 to the 5th power, and if you want to solve it, it'll be 3,125. This works if the bases are the same, and 5 is the base. However, when multiplying powers whose bases are different, we have to evaluate each term separately. We have a 2 and a 5. The bases are different, so each term has to be evaluated separately. 2 cubed will be 8. 5 squared is 25. 8 times 25 equals 200. When dividing powers whose bases are the same, we subtract the exponent. So we have 4 cubed divide 4 squared. Let's break it up so you can see the systems behind it. So 4 cubed will be 4 times 4 times 4. Divide 4 squared, we'll put it on the bottom, 4 times 4. We could cross out, and what we're left is 4 on top. 2, 1. Or we could just subtract the exponents. 3 minus 2 will be 4, 1. We never write 4, 1, we just write 4. I'll explain later in the video. However, when dividing powers whose bases are different, now we have to evaluate each term separately. 12 cubed and 2 squared. Notice 12 and 2, the bases are different. So let's evaluate each term separately. 12 cubed, 12 times 12 times 12 is 1,728. 2 squared is 4. So let's divide the two numbers and we get 432. When raising a power to an additional power, we multiply the exponents. So we have 3 squared in parentheses to the 3rd power. If we break it out, basically we're just asking 3 squared times 3 squared times 3 squared equals what? 3 to the 6th power. Or you could just multiply the 2 and the 3 and you will get 3 to the 6th power. So in algebra, you will have assignments like this. Simplify using multiplication, leave in exponential form. We have 3 squared times 3 cubed. Remember the rule, when multiplying powers whose bases are the same, we add the exponents. 2 plus 3 equals 3 to the 5th power. Same thing, we have bases 5, which are the same. We will leave the 5, and 4 plus 6, 5 to the 10th power. Here we have negative 8 and a positive 10. These are multiplication. We add the exponents. Negative 8 plus 10 will equal 2, 12 squared. Here we have to simplify using division, and we leave it in exponential form. 6 to the 5th power divided by 6 squared. When dividing powers whose bases are the same, the bases are 6. We will leave the 6 because it's the same. We, however, subtract the exponent. So in division, we subtract. 5 minus 2 equals 3. 6 cubed. Here we are still dividing, and the variable n, we will leave it, n. And the exponents, we subtract them in division. 5 minus 2 equals 3. n to the third power, or n cubed. Now remember, this is a division, so we subtract the exponents. Negative 3 minus negative 6 will equal a positive 3. 8 to the third power, or 8 cubed. Here we have exponent of 5 minus 9. That will equal 3 to the negative fourth power. Now, there's a rule. Any number or variable with a negative exponent can be written with a positive exponent as the term's reciprocal. So what we do is we will write 1 over 3 to the fourth power, positive fourth power. So technically in algebra, we cannot leave this answer a negative exponent. Here we have 5 squared in parentheses to the third power. And remember the rule, when raising a power to an additional power, we multiply the exponents. 2 times 3 equals 6. 5 to the sixth power. The base x will stay the same, and we multiply the two exponents. 7 times 2 equals 14. Here we have a negative 3 times a 6. That will equal negative 18. And remember, in algebra, we cannot have a negative exponent in the answer, so we will write it as a 1 over 2 and a positive 18th power. Exponents of 1. So a rule, any number raised to the first power equals the number itself. Here we have 5 to the fifth power divided by 5 to the fourth power. And remember, in division, we subtract the exponents. 5 minus 4 equals 5 to the first power. We never write 5 to the 1. In these cases, it always equals the base number, 5. Another rule is exponents of 0. Any number raised to the 0 power equals 1. So 6 to the fifth power divided by 6 to the fifth power. Remember, in division, we subtract the exponents. 5 minus 5 equals 0. 6 to the 0. In this case, it equals 1. Anytime we have a 0 power, the answer will be 1. So if we have 6,540,354 to the 0 power equals 1. Anytime we have a 0 power, it equals 1.